At this point, we've reviewed the results and might want to have Xpress optimize the design for us. If the analysis shows that your design doesn't meet the factor of safety you were looking for, Xpress can work with one of the dimensions to try and meet your requirements. On the other hand, if your design meets or exceeds your intended factor of safety, optimization can also be helpful to perhaps make the design a bit leaner to reduce material costs. I'll make sure Yes is selected and press Next to continue. Now, a few things change on the screen here. All of the part dimensions are shown, and SolidWorks starts what's called a SimulationXpress study. The SimulationXpress study lets you optimize the design with respect to either factor of safety, maximum stress, or maximum displacement. In this example, I want to see if I can get the factor of safety for this part closer to 5. The first step is to specify a single dimension to adjust to try and reach the factor of safety I'm looking for. One limitation to optimization using SimulationXpress is that you can only optimize one dimension at a time, based on the part's strength in a static loading test. Full versions of simulation have virtually unlimited possibilities for optimization that can explore vibration or buckling responses at the same time as strength across many dimensional variables, since the optimal design is often a compromise between two or more features. It's up to you as a designer to choose a dimension that could improve the design of the part. For simplicity's sake, let's see what happens if I let Xpress fine-tune the thickness dimension to reach our factor of safety. I'll select it in the graphics area and press OK. You can see that the dimensions are added as a variable in the SimulationXpress study. If for some reason you selected the wrong dimension and need to select a different dimension, you can either press the Edit Dimension button in the task pane, or by clicking the arrow under Variables in the SimulationXpress study window. Once you have the dimension selected, you can press Next to continue. What we'll be doing here is telling SimulationXpress a range of values it can try for this dimension and see if it can reach the target factor of safety. It'll run several iterations and fine-tune the dimension within this range until it finds a value, or until it reaches the optimal value. If you click the Edit Dimension Range button in the task pane, flags pop up next to the spin boxes where you can type in the range of values. I'll type in 21 as the minimum and 30 for the maximum. With the range specified, at this point I can specify the constraint for the study. The constraint is basically what we'll be optimizing the dimension with respect to. I'll choose a factor of safety, and I want it to be 5 or greater. I'll click Next. If you look at the bottom of the screen, Xpress shows you that another goal of the study is to minimize the mass of the part. Since optimization will vary the dimension within the range we specified to reach the target factor of safety, it will recalculate values until it finds the right value that meets or exceeds the factor of safety, while still keeping the mass as low as possible. This is a fairly simple optimization, but as I mentioned before, in the full version, you have a lot more flexibility, and you can optimize designs with respect to multiple variables and constraints to reach your goals. I'll click Run the optimization, and Xpress will run several iterations of the analysis, trying different values for the dimensions I specified. When the optimization is complete, I can see the new design meets the factor of safety of 5 as I specified. Without optimization, this could have been a tedious trial and error process to reach the intended results. With the limited variables we worked with here in Xpress, you can imagine how powerful the optimization tools are in the full versions of simulation. To update the model so it reflects the new optimized dimension, I'll select it in the task pane and click Next. Xpress reports that the study results are out of date since the model has changed. To rerun it, I can go back to the Run step in Xpress and click Run Simulation to update all of the results and reports with the optimized design.